Welcome everybody to the IET's Engineering and Technology magazine webinar entitled Enabling Bidirectional Wireless Communication Between IBM Cloud and Bluetooth Low Energy Peripherals through SimpleLink Wi-Fi, which we're hosting in collaboration with Mouser and Texas Instruments. My name's Alex McLeod from the IET's E&T magazine. During this webinar, you'll understand the new low-power and multi-layer comprehensive security features of TI's wireless microcontroller system on a chip and how this technology enables bidirectional wireless communication between IBM Cloud and BLE peripherals. Our speakers today are Beatrice Fankham and Benjamin Moore of Texas Instruments, who will guide us through this process. Before we start, I'm going to briefly run through some housekeeping. You can increase the size of the slides area in front of you by clicking on the Maximize button in the top right of the slides window. You can also press F11 on your keyboard to maximize your screen. Pressing F11 again will bring everything back. You'll see a Q&A box on the right-hand side of your screen. Please submit any questions as they arise during the webinar by typing them into this box. Answers will not be displayed. Instead, towards the end of the webinar, about 45 minutes in, we will answer the questions that have come in. Please don't miss out on this opportunity and submit your questions early. We'll endeavour to reach all your questions, but any we don't get to will be followed up afterwards. During the webinar, if the slides aren't moving in front of you, you may need to refresh your screen by pressing F5. For slow connections, you might need to do this regularly. I'd like to highlight a few of the widget buttons along the bottom of your screen. You can open a widget simply by clicking on it and then close it by minimizing, dragging, or resizing it to anywhere on your screen. If you're having technical issues, please click on the yellow question mark widget at the bottom left, which directs you to our help pages. Here, please test your system, check minimum system requirements, and review the FAQs. If an issue persists, submit the problem to us in the Q&A box. You'll notice the IET resources list on the right-hand side of your screen. You'll see a link entitled "This webinar will go towards your CPD." You can go to this link, log into the IET's Career Manager, which is under the heading "How is the IET supporting me in this process?" and register for CPD credits for attending the webinar. If you cannot see the IET resources list on the right, please click the grey widget or put your request in the Q&A box and we'll send you the website link you need. Everyone will receive an email within 48 hours with a link to the recorded event so you and your colleagues can go back in, view the webinar, and also submit questions to the speakers after the event. Once the live webinar has finished, you can't immediately submit questions. You have to wait for the recording to be available. Finally, in the center, you'll see a black clipboard widget. Please click on this to give us your feedback in 3 easy tick boxes at any time during the webinar. Okay, enough housekeeping. I'm going to hand over to Beatrice and Benjamin.
Thank you. This is Beatrice Fankham from SimpleLink Wi-Fi team. Today we're showing you here the agenda of the overall webinar. We will start with an introduction of the SimpleLink MCU platform, which is a core SDK that is being leveraged by the 2 devices that will be used. The SimpleLink Wi-Fi CC3220, a single-chip wireless MCU, and the SimpleLink Bluetooth Low Energy CC2640. We will then continue with the overall system design for the gateway of the BLE peripheral. It will start with an overview of the system diagram. Then we will show you how we're enabling network connectivity. And we will continue with the interface between the CC3220 and the CC2640. We will then provide an explanation of how we leverage the MQTT client to enable cloud connectivity, then continuing on to the setup of the IBM Bluemix. We will continue with showing you how to leverage the existing sample code in the SDK that was already released by TI, and show you how you can build your own gateway. In order to conclude with the presentation, we'll show you all the development resources that you will need in order to build your own gateway. Before we get into the SimpleLink MCU platform, let's start with the top IoT concerns that all developers have to address when designing a wireless connected product for everyday users, especially products that have already a BLE technology integrated and also need remote connectivity in order to be remotely controlled by the user. In a recent study by Bain & Company, there were more than 100 executives at IoT and analytics solution vendors looking to deploy this solution, and their top concerns for implementing IoT solution included the following: an increasing need for enhanced security measures. Let's face it, the information is going through the cloud and your information needs to be secure. The continued evolution of connectivity standard and the associated complexity of them. In this case, we're mentioning a BLE and also Wi-Fi. There may be other technology integrated to the platform. How do you go about integrating those technologies, those complex technologies? And on top of that, the required actually expertise that is needed to develop this solution, given the limited resources within the company for internal development. This is really where TI enables the developers to leverage our solution because we make it easier for them. And to close on this one, given that most of those end design are battery powered, there's a technical limitation that comes with power consumption. Today, we will show you how this concern can be addressed by leveraging the BLE and the Wi-Fi solution from Texas Instruments. In order to address the complex standard that is one of the top IoT concerns when designing a system with several technologies, in TI of 2017, TI introduced a new SimpleLink MCU platform. Really, this one is intended to make it easier for customers to adjust and adapt to changing design or application requirements. The new SimpleLink MCU platform brings together industry-leading technology solutions with TI-proven ARM-based MCU. This platform provides a single development environment based on a common core SDK across these devices. For instance, the MSP432 as a microcontroller, the BLE low energy in the CC2640R2S, the sub-1 GHz solution with the CC1310, the dual band solution, and also the Wi-Fi solution, both in the CC3220 as a wireless MCU and the CC3120 as a wireless network processor. Today, for the remainder of this presentation, we will focus on the SimpleLink Wi-Fi CC3220 and the Bluetooth Low Energy CC2640R2S. This is a representation of the core SimpleLink MCU SDK that will be leveraged between the CC3220 and the CC2640R2. As far as the main component, you'll see the TI driver, which is a portable feature-rich access to peripherals, and the driver lib, which is a hardware abstraction layer access for device-specific optimization. On top of this driver, then you have several different middleware based on the technology that you would need to use. We have the BLE and the Wi-Fi middleware, for instance. This SDK supports real-time multitasking operating system, and it also has POSIX-compliant API, which enables the use of a variety of RTOS kernels, validated on TI RTOS and free RTOS. Now, let's first start with an introduction of the SimpleLink Wi-Fi CC3220. This is a single-chip wireless microcontroller, a fully integrated system on chip, which raises the bar for all embedded Wi-Fi with regards to the low power, security, and enabling time to market for the customers. The SimpleLink Wi-Fi CC3220 is actually the second generation to the SimpleLink Wi-Fi family of devices. Just like the previous generation, we continue to be the lowest power Wi-Fi devices on the market. For instance, for a system power with 2 AA batteries, we can achieve several years, depending on the profile that is selected in the system during runtime. we've identified mainly 3 profiles that are commonly used. The first one is the always connected profile. In this particular profile, the system always stays connected to the network, and it enters a low power deep sleep when there is no communication with the network. In that particular profile, we can achieve up to 1 year of battery lifetime. For the second profile, known as intermittently connected profile, in which the system will actually disconnect from the network and enter hibernate mode. In this particular profile, we can achieve up to 3 years of battery lifetime. For the last profile, that was named transceiver profile, most of the time applicable to tag type of application. In this particular profile, there is no need to reconnect to the network. The device will wake up, send a few packets configurable by the developer. With this one, you can achieve up to 5 years of battery lifetime. Now let's consider the security concern that needs to be addressed by developers. In order to address those, TI has invested in the SimpleLink Wi-Fi device, which is a device that comes equipped with multi-layered security features. Most of the time, when people think about security for cloud-connected products, they often think about the data exchange between the Wi-Fi device and the local access point. But when examining the system topology end-to-end, there are actually several additional exposure points to consider. Within the transfer stage from the end product through the local access point, all the way through the internet to the end user that is controlling the product at a remote location, and sometimes connected to the original vendor server, for instance, during an over-the-air update of the application. They also need to consider the storage on the end product and the IP that is running on the product and anything that is running during runtime. This is where the SimpleLink Wi-Fi comes in. The simple single-chip wireless MCU has a wide range of features which will help developers design security measures that take into consideration all these access levels for their products. There are several features for the physical access level, the local network access level, and as well as the remote access level. We will not go into the detail for each of the features mentioned here. But just imagine that you had designed your end product with the SimpleLink Wi-Fi TC3220 within it. You will have all of these features integrated within our device and therefore within your product. You will be getting here a comprehensive end-to-end security with a rich set of features to allow protection from hostile takeover, theft of personal credentials, and also prevent any modification of the system code. With this, you have a fully comprehensive security system that will reduce the need to need any other external secure element. Now let's look at the architecture of this SimpleLink Wi-Fi TC3220 that is enabling low power and application to run on 2-way batteries for several years and also provides several security features. What is its architecture? First, it has 2 cores within one single IC, the application MCU based on ARM Cortex-M4 and the network processor. First, let's look at the component within the network processor. This network processor offloads all networking and internet tasks from the application MCU. It supports 2.4 GHz for 802.11bgN. It also supports the Wi-Fi in station or in access point mode, as well as Wi-Fi direct mode. In access mode, it will support up to 4 stations. It offers several provisioning options in the AP mode, the TI proprietary smart config, as well as WPS, and it is also compatible with WAC, which is Apple proprietary configuration, network configuration. It has integrated built-in power management with an integrated DC-to-DC to support direct battery connection. It will It will take an input voltage supply from 2.1 to 3.6 or pre-regulated 1.85. It has also the low power modes, which are actually leveraged heavily in order to implement various profiles. The hybrid NIC will consume 4.5 microamp. The low power deep sleep, which is leveraged in the always connected mode, will consume 135 microamp. It's important to note that for the low power deep sleep, this current consumption is actually the current consumption for the whole system, the application MCU and the network processor. This is very low for integrated microcontroller with Wi-Fi solution. It also has within it an Internet and application protocol, and several ones such as the embedded web server, which HTTPS. It supports IPv4 and IPv6 TCP/IP stacks. It also supports 16 sockets, 6 of which can be simultaneously secure. It has within it a powerful hardware crypto engine that are leveraged for several security features. Within the network processor, it is leveraged to enable a fast, secure internet connection within 200 milliseconds, which is also helping for establishing a fast connection to the internet and also maintaining a low power profile. This device supports industrial temperature from -40 to +85 degrees C. Now, let's look at what is in the application MCU. This is really where the developer writes their code. This is a physically separate MCU in the same chip. MCU and memory fully dedicated to the user application. It has several peripheral drivers and libraries. It will support a system without an operating system, or it will also work on TI-RTOS and FreeRTOS. The integrated application memory has 256 kilobytes of RAM, and we do provide another variant that will give you an additional 1 megabyte executable input flash on top of the 256 kilobytes of RAM. The reset of peripheral consists of 27 I/O pins with flexible muxing options. You'll see them listed here in the UART, SPI, SD card, and also 4-channel 12-bit ADC inputs. Within the application MCU, we are enabling several security features that we just presented to you. Mainly those features are there to help you protect your software IP and also any data and credentials stored on the device. We're also providing API access to several hardware crypto engines such as AES, DES, SHA, and MDR as mentioned here. This device also supports HomeKit technologies. So you can enable your product and design your product to be connected with a HomeKit technology, enable and connect to Apple type of cloud. We also do provide support for over-the-air updates. And as I've mentioned before, it is part of the SimpleLink Connected MCU platform. This device was actually conceived from the first generation in order to bring the multi-layer security features to this type of market. We have within it, again, the Wi-Fi security features, the internet level of security features, and also several features such as encryption, authentication, file protection in the application and file security system. You can read more about the application and file security feature and all of the security features within the app note that we have posted on our website. On top of integrating the security features, this device, again, is enabling any application to run for several years on 2 AA batteries. This, of course, will depend on the profile, the low power profile that you choose to enable within your application, and they are all configurable at runtime. Now that you have seen a brief introduction of the SimpleLink Wi-Fi CC3220, let's look at the SimpleLink Bluetooth Low Energy CC2640R2F, the ultra low power wireless MCU from Texas Instruments. The CC2640 belongs to the TI Bluetooth Low Energy Wireless MCU portfolio. It has several devices within this family, the CC2540, and it also has pre-certified module. The CC2640 is the latest device from this portfolio. It comes equipped with several features. It provides the lowest power for any BLE solution on the market. It gives multi-year on a coin cell. Now we're moving from a battery, from 2AA batteries to a coin cell with the BLE device. It has an integrated Cortex-M3 MCU and a radio with automatic power management. It comes in highly integrated as a single chip as well, and a flash-based wireless MCU. It also has integrated the unique sensor controller in a tiny 2.2 by 2.2 package. It is very easy to design with because it has a comprehensive set of design support, and it's also based on the SimpleLink MCU core SDK platform. We provide several design kits and low-cost tools. Now, let's look at this architecture. Now, let's take a deeper look at the internal architecture of the CC2640. This system-on-chip wireless MCU from Texas Instruments, which provides the lowest power, and it's a highly integrated device. Within it, it has an ARM Cortex-M3, which is dedicated to the customer application. It can run profiles and services if they're using one of the software stack provided by TI. It will support the TI Atos and the TI supported software framework. It also integrates peripheral drivers and library provided directly by TI with at free royalty for the protocol stack. For the low power, as you can see the numbers here, is very low for this type of architecture. In sleep mode, it will consume 1 microampere with memory retention and RTC. For receive and transmission, then we consume about 5.9 milliamp and 6.1 milliamp respectively. As I mentioned, it comes integrated with a sensor controller engine, and it will take a couple of different input voltage. It comes in several different packages from 4x4 to 7x7 millimeter QFN package. It has a very flexible RF performance. It's offered as a single-ended for low-cost consideration, or also comes equipped with differential for high-performance type of application. The output power is 5 dBm, and the sensitivity can be as low as -1 or 3 dBm for BLE at 125 kilobits per second. This is the SimpleLink Bluetooth Low Energy CC2640R2 that will be used in this system design. Now that you have seen a quick introduction of the SimpleLink MCU platform, the CC3220 and the CC2640, we want to show you how you can leverage these technologies and solutions from Texas Instruments to enable Wi-Fi gateway for BLE peripherals. In this particular design, we're showing you how to retrofit, for instance, an existing electronic smart lock that has BLE integrated within it. Now we'll hand over the presentation to Benjamin Moore.
Thank you, Beatrice. Now let's dive deeper into how we can use these devices to enable bidirectional communication between BLE peripherals, such as a smart lock, and the IBM Cloud. Let's first consider a BLE-enabled device, such as a smart lock. Using BLE as the primary connectivity solution in a lock allows a user to control the lock directly from a mobile application on their phone. This is great because it helps eliminate the need to search through a key ring for the right key, and it makes it easier to manage who has access to the lock. However, a BLE-only smart lock solution is limited to just local control. Adding a Wi-Fi connectivity option through a Wi-Fi to BLE gateway system enables new use cases for the lock, such as being able to monitor and control the state of the lock remotely, as well as being able to perform user authentication in the cloud, which can provide more flexibility to the user. It will allow them to add or store temporary keys from anywhere. So let's look at some of the key features of the CC3220 and the CC2640R2 that make this possible, such as integrated provisioning, common drivers, pre-built libraries, and example applications. The first piece of the design we need to consider is how we would connect the gateway system to our local network. A Wi-Fi to BLE gateway is a headless device, meaning it wouldn't have a traditional user interface for the user to enter network information. To connect the gateway to a network, it would have to be provisioned to the network wirelessly. The CC3220 has provisioning integrated into the network processor, which makes it easy to include in any application. Two of the key provisioning methods it supports are access point or AP provisioning and smart config. With AP provisioning, the SimpleLink Wi-Fi device starts up as an access point. A user connects their mobile device to its network and then passes the credentials directly to the device. With Smart Config, which is a TI proprietary provisioning method, the user is able to simply connect the CC3220 to the network that their mobile device is already on, without needing to directly connect to the CC3220 first. In the Wi-Fi gateway system, the host application would only have to trigger provisioning if it didn't automatically connect to a network from a stored profile. And this really enables the device to save power. While provisioning is running, the network processor built into the CC3220 sends events back to the host application to indicate different steps in the network connection process, such as whether the device is connected to the wireless local area network and whether it has acquired an IP. These events signal that the device is successfully connected to the network and that the device is ready to run the main application. With integrated provisioning in the CC3220, triggering the provisioning process from the host microcontroller can be done by calling a single API, SL_WLAN provisioning. All you have to pass the command is the provisioning mode you want the device to use, whether it's AP, Smart Config, or some external provisioning method, or possibly even a combination of provisioning methods, as well as the role you want the device to enter upon completing the provisioning process. And then additionally, you can give provisioning some sort of inactivity timeout so the device doesn't stay in a provisioning state if it doesn't need to. Built into the provisioning process is a key step needed to ensure that the device receive the right network credentials and provide this feedback back to the user. We call this the confirmation step. The confirmation step helps to make sure that a user knows when the Wi-Fi gateway successfully connects to the intended network. As part of the integrated provisioning feature, the CC3220 supports the ability to run multiple provisioning modes simultaneously, such as AP provisioning and Smart Config at the same time. And this is great because it simplifies developing the software application that the device will run, because the same code can be used to support either provisioning method. And that means that no changes would be necessary to the application code if you want to support one, the other, or both in your mobile application. Once the Wi-Fi gateway is connected to the network and to the internet, the next step is to start configuring the BLE connections. In the case of the Wi-Fi gateway for BLE peripherals, the CC2640R2 can be used as a network processor to enable the system to act as a BLE central device. This lets the gateway support multiple connections to peripheral devices at the same time. Configuring and managing the connections through the CC2640R2 can be achieved by running the host test application that's part of the CC2640R2 SDK. When running this application, the CC2640R2 accepts host controller interface commands, or HCI commands, as well as some vendor-specific commands over either a UART or a SPI transport. Since both devices are part of the SimpleLink MCU platform, TI drivers can be leveraged to implement the UART or SPI interface driver. And as a result, the drivers for the controllers will be similar and provide maximum portability to other SimpleLink platforms. A basic HCI command flow that can be used to identify and establish a connection to BLE peripherals is shown here. First, the CC3220 host can use the device init command to set up the CC2640R2 in a central role when it's acting as a network processor. Then, the device discovery request can be used to identify nearby peripherals. Next, the CC3220 can select the BLE peripheral it wants to connect to using the received advertising reports, which contain addresses of nearby BLE peripherals. With the address of the BLE peripheral, the establish link request command can be used to establish the connection. Once connected, the read and write characteristic value commands can be used to write and read characteristics on the BLE peripheral device. With the Wi-Fi gateway connected to the internet via the local network and to the BLE peripheral, such as the smart lock, it can start sending and receiving data from the cloud. An ideal protocol for updating the cloud with the peripheral state and receiving messages to control the peripheral is the Message Queue Telemetry Transport Protocol, or MQTT. It's ideal for an embedded system like this gateway because it's a lightweight protocol and it's based on the publish-subscribe model. Being based on the publish-subscribe model means that client devices using the protocol send messages to each other by publishing them to a central broker first. The broker then distributes the messages to all other clients subscribed on the topic the message was published on. This provides the benefit of allowing the network of connected clients to scale through the cloud vendor. And it's really easy to add MQTT client functionality into a SimpleLink Wi-Fi based design because there's an MQTT client library included in the CC3220 software development kit. The MQTT client library from the SDK can be used to quickly connect to a cloud server such as IBM. And in fact, we provide an example of connecting to IBM's demo server as part of the SDK as well. However, connecting to a custom MQTT host using the library requires only updating a few key parameters used by the library. For example, a user can quickly update the address of the server they connect to and set the port number that they connect on in the MQTT client NetApp connection parameters structure. Some of the basic MQTT client APIs can then be used to set some additional parameters of the connection if needed, as well as create the client context and run the client. Once the client is running, the application can control when the client connects to the server, subscribes to topics, and publishes to topics using the API call shown here. The last piece to creating the gateway system is setting up the cloud service for your device. A great service for quickly developing, deploying, and managing a cloud application like the one for the gateway is IBM Bluemix. IBM Bluemix is an implementation of IBM's open cloud architecture that is based on Cloud Foundry. We can use IBM Bluemix to connect the Wi-Fi gateway to the IBM cloud and create a web interface to monitor and control any devices connected to the gateway. Now I'm going to review how we can do just this. By following these steps shown here, we can generate credentials that can be used directly in software to let an MQTT gateway connect to IBM Watson and interact with another connected client, such as a PC, phone, or tablet. And of course, the first step we're going to have to take is to go to IBM Bluemix and sign up for an account. Once you log in, you'll have to create an organization and a space for developing your application. Organizations are intended to represent a logical grouping of project resources. They can be used to distinguish between different sets of team members working on projects or specific services and resources of your cloud service, such as available memory. Each organization will have its own domain or set of domains and act as a unique identifier across all of IBM Bluemix. Within an organization, you can further divide applications, services, and team members into spaces. Each space will be tied to a specific region, and in the example shown here, I've named the space DevSpace to represent that it's my development environment, and to distinguish it from any other space I would create for a production or release environment. Once the account is set up, the first thing we're going to do is create a new application. When we hit Create App, we'll be shown a couple different options for services that this application can use. In this list, we'll choose Internet of Things. And finally, we'll get to choose which type of Internet of Things service we'll want to use, and we'll choose Internet of Things Platform. This is going to be our Watson IoT app that the Wi-Fi gateway directly connects to. Now that we have added our IoT app, we have to add a device to our account. And first, before we can actually add the device, we'll have to define the device type, so any associated applications know how to interact with it. The gateway type is already a known category of device, so when we create the device type, we'll just choose Create Gateway Type. This will act as a template for the device type that we fill out some information for. We'll type in the name of the gateway, type, here I've specifically called it My Wi-Fi Gateway, and fill in some basic information about it. After we've finished creating the device type, we can add the new instance of the device to our account. When we've finished adding the gateway to our account, a set of credentials will be generated. These credentials will be used as part of our MQTT client to allow the gateway to authenticate and connect to our specific application. The last part we have to add to our IBM Bluemix account is a Cloud Foundry app. And for this, we'll select a Node.js SDK application so we can create our server-side JavaScript application that will provide the remote interface to the gateway system. Once the app is created, we can follow the instructions for configuring the app with the Cloud Foundry command line and push our code to our account. Now that we're done configuring our IBM Bluemix applications, we can use the generated MQTT host information and the device credentials to update our CC3220 code. And this will let us test out our connection and actually start using the gateway and any connected BLE peripheral devices. The first thing we want to update is changing the server address that was generated from our IBM Bluemix setup to be used by our MQTT client. Next, we will use the device credentials that were generated when we added the gateway instance to our account. The first three of these are Organization ID, Device Type, and Device ID will be used to set the client ID used by the MQTT client. You can see here we'll start with a G for the gateway, and then that will be followed by the org ID that was given for our organization we set up. Then we'll add the device type name that we added. In this case, it was My Wi-Fi Gateway. And finally, we'll give the exact device ID of the device we're using. In this case, it's Wi-Fi Gateway 1. And then we'll go and we'll update the username and password that this client uses to authenticate with our MQTT broker. The first will just be a constant string that says use auth token, and that tells the server that we're going to use a password or authentication token to authenticate. And then the password will be the authentication token that we set when we set up the device. Here it's my gateway password. And that's all there is to it. The best part about this gateway design is that all of the software components needed to create it can be found as part of the Simplink software development kits for the Simplink Wi-Fi CC3220 and the Simplink Bluetooth Low Energy CC2640R2. And the software can be run on the CC3220 and CC2640 launch pads to let you quickly prototype the system and allow you to focus on your application. Some of the different software resources located within the SDK for each device are shown below. The first step to get started on your project is to order the development boards from the TI store. You can go to ti.com and order both the CC3220S Launchpad and the CC2640R2 Launchpad, both of which you'll need to create your gateway design. Then you can go and download the CC3220 Software Development Kit and the CC2640R2 Software Development Kit to get access to some of the main software resources you'll want to use. You can take these SDKs and follow the Getting Started project to set up your environment for development, and then use the example code to build the gateway. Afterwards, you can follow the steps we've outlined here in the presentation for setting up your IBM Bluemix account and actually creating your cloud application. Then you're on your way. Just start developing your own gateway for BLE peripherals. Now I'm going to hand it back over to Beatrice so she can talk about where you can find some of these resources and how they all fit into the SimpleLink MCU platform.
Thank you, Benjamin. All development resources that Ben just mentioned, from the ARM-based MCU, the software development kit, and our development platform are all available on TI.com. And we provide much more with the TI Resource Explorer, a free cloud-based code composer IDE, and the SimpleLink Academy for online self-paced training. And you can visit, respectively, the TI.com/SimpleLink Wi-Fi and the TI.com/BLE for specific information on these two technologies. All of these devices, the SimpleLink Wi-Fi CC3220 and the CC2640, are part of the SimpleLink MCU platform, which enable the combination of several technologies into one design. It's important to see that and to realize that the number of BLE-enabled products have grown exponentially on the market. All those products are usually controlled by local wireless mobile devices. However, there are several instances where it's desirable to access them remotely. This is where the Wi-Fi component comes into place, because adding a Wi-Fi to a system then enables a gateway to those BLE peripherals. Take, for instance, an electronic smart lock that already has a BLE integrated. In order to enable the remote connectivity, one can design a gateway, such as the one that we've explained in this presentation, in order to enable that remote connection. Today we have shown that how it can be done with the CC3220 and the CC2640 SimpleLink MCU platform. So you can go ahead and get started with your own design today. Well, I would like to thank you for your time and your attention today, and mainly giving us the opportunity to present to you the SimpleLink MCU, the CC3220 and the CC2640R2, and how they are used to enable bidirectional wireless communication between the IBM Cloud, the BLE peripheral, through SimpleLink Wi-Fi. And now we'll open the session for question and answers.
That's great, Beatrice. Thanks very much. So, everybody, we have a few questions that are going to come up. Let's take a first look at those now. So the first question that we have is possibly one for Benjamin. You mentioned that the CC3220 supports non-OS TI, RTOS, and FreeRTOS. Can the CC3220 be used with a different RTOS if desired?
Yes, that is correct. If so chosen, the CC3220 could be used with a different RTOS if you have a different one that you prefer. And actually, all of the examples in the SDK, they're built with the POSIX implementation. That's the Portable Operating System Interface. So we make it pretty easy to switch out to a different RTOS or a non-OS example if you need. The one advantage of going with a TI RTOS solution is that that kernel is developed internally at TI, so it's really easy for us to support all the way through.
Okay, great stuff. And just a reminder for anyone that does have a question, feel free to place that into the Q&A box on the right-hand side of your screen, and we'll get to those as soon as we can. The next question that we've got in is possibly one for Beatrice, this one. Is the SimpleLink Wi-Fi CC3220 offered as modules as well?
Yes. The CC3220 is offered both as Q&A and also as a module. We will actually be offering two variants of the modules. The first one will be module without antenna, which have already released at the end of June. And these modules have the full regulatory certification from around the world: FCC, ICCE for Europe, TELEC for Japan, and SRRC for China. You can find more information on our webpage, ci.com/product/CC3220 mod. In the mid of August, we will also be releasing the second variant, which will be modules with antenna integrated on the board, and the customer can actually use this module as a plug and play. No other RF components will be required on the final PCB.
Okay, great stuff. It doesn't appear that we've had any other questions in, so thank you very much though to Beatrice and Benjamin. So that brings us to the end of today's webinar. Thank you everybody for attending and looking at the webinar. Please note that you'll receive an email within 48 hours with a link to the recorded webinar so you and colleagues can go back and view. And if you do have any questions or queries, then do feel free to plug this in. So we have actually had another question in. We've got a little bit of time, so I'm just going to throw this one out to Benjamin and to Beatrice. The question is, will a Zigbee Wireless MCU appear anytime soon?
Beatrice, can you comment on that one?
Yes, so this is something that I'll have to provide as an answer after the webinar. This is actually being driven from another team, but we do have a Zigbee device already available from Texas Instruments. As far as a wireless Zigbee, I have to get back to that question.
Fair enough. Okay. So to the person who posed that, we'll get back to you. So another question has come in, which is, how can we utilize Wi-Fi for vehicular communication?
Can you please repeat the question?
Yeah, how can we utilize Wi-Fi for vehicle communication? So within automobiles or trucks or some sort of
in a vehicle
communication. Yeah, sorry.
Okay, all right. So it really depends on where within the vehicle the Wi-Fi will be integrated, right? So we have within TI two types of Wi-Fi devices. One is the WireLink 8, which has an automotive-graded variant, and the particular one that we discussed during this presentation is the SimpleLink Wi-Fi. It does support industrial temperature from -40 to +85. In the vehicle, some of the time there's a requirement for a wider temperature range. So if the application requires a wider temperature range, we would most likely recommend something like the WireLink 8 automotive-graded device. If it does not require the wider temperature, then depending on the application, it could be used as an integrated wireless MCU within the system, for an application that requires low throughput. It really depends on the application to be able to provide more specific answers. But
Okay,
the temperature is something that should be taken into consideration.
Right, for sure. Another question which I'm not sure whether you'll be able to answer over the telephone, but maybe we can make this one our final question. So it's great that we've had some audience participation. And again, if you want to submit a question, feel free to. So we have, do you have any gateway example with the CC3200?
So there isn't a full gateway example for the CC3200, but kind of all of the components that we've talked about here could also be done with the CC3200. It's similarly in its SDK, which is not part of the SimpleLink MCU platform. It has its own MQTT library and has the ability to do exactly what we've shown here with the 3220, which is interface with a CC2640R2 as a host and be used in a gateway example.
Okay, thank you very much for the answers there. I guess the final thing for me to say before we close off is don't forget to register for IET's DPD credits via the resources widget for those of you who are IET members. and fill in the very short survey to give us your feedback. The webinar console will be unavailable just while we prepare the recorded version, the on-demand version for this. So follow the links from the email that you'll get within the next 48 hours. And thank you very much indeed for watching. Bye-bye.